Today we're going to look at how to use the environment query system in Unreal with state trees. And we're going to create a mechanic where whenever our NPC or AI character sees our player, he's going to flee and find somewhere to hide using the EQS system. So hopefully at the end of it we'll have something like this, where he sees us, he runs away, keeps running away. Now when he finds a position, he checks to see if he can find us, and whenever we chase him, he'll keep looking for a position where we can't fully see him. So we can just carry on chasing him, and he'll keep hiding and then fleeing from us. And we should never be able to catch him, essentially. So let's get started with this state tree and environment query system video. So the first things we'll need to do, you'll need to make sure, is that you have certain plugins enabled. So if you just type in state tree, you'll need to enable the state tree and the gameplay state tree plugins and then restart your editor. The other thing we're using is the environment query system. That's already enabled by default, even though it is experimental. It seems to work in most cases. So once you've restarted, we'll just open our level and basically just set up a level. I've added a nav mesh to it, which make sure you do add. So that's just nav mesh bounds volume, and then just make sure it envelops the entire just scale it up to envelop the entire area, and if you press P you can get to see what it's covering with that green color. Our player character is just a duplicate of the third person player character. Nothing has been changed, and there's just a game mode and a player controller, again in order to set everything up in the world settings. So it uses our player character and player controller. Change that to EQS. I've made some videos on state trees before, which I'll link to, but to create our state tree, if we right click, go to artificial intelligence, we should now have state tree here, and this is obviously the environment query. But we'll start off with the state tree first, and we'll go for state tree AI component because we'll put this on an AI controller. So state tree, we'll just call that EQS. We'll need an AI controller to host this state tree, so we'll right click, blueprint, to check for AI controller, and we'll just go for the normal AI controller. That will be our AIC EQS. If we just open that, we can then add a state tree component to this, and again we'll go for the state tree AI. So we can set our state tree here, which is state tree EQS, and it's set to start logic automatically, so hopefully that's what it will do. So that's the AI controller and the state tree attached to it. Now we'll also need obviously a character that hides and flees. So let's create one of those. Blueprint, character, and we'll go for BP hide flee character. We'll open that, we'll give it a mesh, many, position and rotate it, and give it an animation blueprint many. we'll need to set its AI controller to be the one that we created. So if we go to AI controller on the character, the AI controller class here, we can pick our AIC EQS. So let's open our state tree, double click, and start creating some tasks. So that's the root task. We'll make this quite a simple state tree. So let's create one. Just click there, add task, add child state. We'll just call this hide and flee. And this will require a task. So we'll need to create our first task. So we go here and we just say, go to blueprint and go to state. And what we're looking for is this state tree task blueprint base. If we select that and call this our state tree task hide and flee. We can open that, and in a task, so they start off with the enter state, so we'll open that. We'll want to have access to the actual AI character that we're using. So if we create a variable, call that our AI character and set that as a character. Object reference, we can expose it. Let's compile this, and if we go to our state tree again, we can click on this, maybe just add a child state and call that the hide task. Click on the plus. Now you notice that some of these things come under a category, whereas ours just comes as appears there. The way that you can get it to show under a category is if you open your task, go to the class settings or the class settings, and here it says blueprint category. If you just maybe type in EQS, compile that, go back to your state tree, hopefully that shows up as so now we get a new drop down. We can choose our hide and flee task. So we'll need to connect this to the actor that is represented, or that is connected to this state tree. So you can change the context actor class here. We know ours will be a character, so we can change that to character. And then you can either, on this side, just click on actor there, or as I showed you previously, to get that to be done automatically, if you go back to your hide and flee, go in your variable, and in the category, change that to context. And compile. And then back to your state tree. So now it's automatically linked because the context corresponds to the actor context, and that saves you having to do that for every single task that you create. So what is the environment query system in Unreal? How do we create an environment query and how do we run it? So the environment query essentially allows you to query the environment for locations that meet certain criteria. In our case, we want our AI character to find a location that is not visible from the player's position. In other words, it is hidden, and for it to then move to that position. So to create our first EQS or environment query, so we right click, go to artificial intelligence, and we click on environment query. So this can be our EQS hide location. So this should find us a hide location to move to. So if you open your EQS, you end up with basically just a root. And using this route, you now need to run a series of tests that will filter the locations which are coming back and give them a score, and then return that score and locate that location with the highest score back to you to choose. So basically on the route, if you go down, you can only pull off one arrow. What we want to do is we want to create a points around our AI character in a grid which it is able to navigate to first of all. So we'll create a grid of points around our character. On this side, when you click on the node that we just created, which is our main node, you've now got access to a lot of information. So one, you can set the size of the grid. We'll make that 1500. It's got quite a large area. You can set the space between each of the points that is created. We'll leave that at 100. And then you've got a context, and the context tells you what is the center point around which this grid will be created. We'll leave that as query because we want to create it around our character, the AI character which is running this query. You can also set other information, so you can project it up and down, add things to it, and so on, but we'll leave all the rest as is. Now this isn't particularly visual, so if we go back to our main level, you can create what's known as a testing pawn. So go to create a new blueprint, and I think it's called testing, that's right, so EQS testing pawn. Click on that. We'll call this our EQS test pawn. We can just open that and we can maybe give it something to look at. So that's Manny. So that's how it should look like visually. Then we can drag this pawn onto the main level. And if you click on the pawn, go to the details, and you go down, there should be an EQS category, and here you can choose the template. So we created an EQS hide location. And now these are all the points which have been identified, which our character can navigate to using the mesh in a 1500 sort of half grid size, and each point is separated by 100 as we set it here. So that gives us all the grid locations. Now we want to add some tests, because we want essentially to find that the path, that there is a, first of all we want to find that there is a path to each of these locations. So at the moment it will identify locations which may be unreachable. So if we go back to our, if you right click, go to add test, you can now say, we can maybe do this pathfinding batch, not sure what the difference is, but anyway, and click on that. And now we can say, we can test to see, does a path exist from the querier, which is our pawn, to the grid to one of those points which has been identified. So path exists to the querier. We can leave everything the same, and we want to know, so when it runs the test we want to get the results back which match the test, i.e. that a point exists, and we'll just filter out the points which are not reachable. So as you read here, it says discard unreachable, requires existing path. That might not, see if that changes anything. So again, we get all the same paths, but we've told it not to score it, so they all come back as 0. The next thing is, what we want to test for is, can the player see, so in essence, from each one of these points, is it visible to the player? If it's not visible, then it means it's a hidden point and we can move to that location. So we want to do a visibility check on each one of those points. So we go back to our EQS, we can add another test, and this will be a trace. So we'll trace, and we'll tell it to, again, we'll filter. We'll filter out the points which it can see. So how do we do that? So again, we don't want to, if we could click on the query here, we can do a trace. So we'll trace by channel. We'll do that on the visibility, and maybe we'll do a sphere trace, just so that it gives us a wider trace shape. And we'll maybe give that sort of 30. We'll tell it to trace complex. We want blocking hits because what we know is that when it comes to collision channels, and I think I've done a recent video on how you can create your own custom collision channels. The player will not block the visibility, but it will block the camera. All of these other items, these world static or world dynamic objects, will essentially block the visibility. So if we trace from the player across and we hit something on the visibility channel, it means that that is blocking the location behind it. So for instance, these locations, we trace from here to here, this wall will get in the way. So we'll trace on the visibility, we'll do a sphere. We want the ones that block, and we want it to return the matching to match. In other words, the ones that pass the test, we want to come back, because those are areas, those are locations which we could move to. Now this is where we need to make some changes. So the context, currently it's a querier, which would be the AI character. We want to trace from the player, so we'll need to create a new context. So if we go back here, we right click, blueprint, and we check, if we type in context, we should get this environment query context blueprint base. So we can click on that, and this can be our EQS player context. And if we open that, so the way this works is, if you go to the override, we want to return a single location, so just the location of the player character. So we'll click on that. This will come back with the AI character that is running the query. So what we'll need to do is we'll need to get the player character. Actually, what I've done is I've put a player character onto the actual level, and I've set it to be possessed by the AI controller. By the player controller. So we can just check for the actor of that class, which is the player EQS character. So go back to our context. We don't need that. We can say get actor of class, and that will be the player EQS character. We'll say if that is valid, we can just send back the actor's location, get actor location. If it isn't, we can just send back the querier's location in this case. So that will get the player character, get its location, and return that in the provide single location context function. compile that, save that, and just set this, save on compile. Probably close that. If we go back to our EQS again, we can now change the context here to our new context, which is EQS player context. So now it will trace from the player to each one of those locations on the grid. Does that change anything? So we click on our character again. Again, we're not scoring it, so things might not look normal. So if we do a score on there, so we go to the EQS on player context, change that to score. Again, it stayed the same. The issue might be that we're tracing from the floor upwards. If we go back to our EQS here, you can also change the height at which the item is set. So if we want our points to trace from the eye location, we can maybe set that higher. And now you see that the points that we are getting are the ones that are not visible to the player. So they should all be hidden from the player. So the green ones, and they all score 1. When we come across here, the red ones can be seen by the player, so they get 0. And these ones are all hidden, so they should get a 1 as well. So these would all be the locations that our AI character could run and hide in to not be visible by the player. And if we sort of move our testing pawn and we move our player to a different location and then click on the testing pawn, we should get different results coming through. So again, it will still keep finding the locations which are not directly visible with a sphere trace from the player's location. So now we have our first basic EQS query. The question is, how do we run this on a state tree? Because we go to our state tree and we maybe click on a task here, another task, or we just open this. There is no run EQS query available on here, because those of you who use behavior trees would be aware that it's slightly different on a behavior tree. So we just create a behavior tree, open it there, we just put a selector, and then we come down. There is a run EQS query node available, and you can then just pick the template that you want, and it will run that query and give you access to, and then allow you to set the single best item that comes through. What's also interesting is if you click on here, you can actually run a state tree from a behavior tree. So you can click there and you could pick our EQS tree as well. But we're not going to be doing it this way. So let's just close. So obviously we don't have this node in the state tree. So if we close that and we go to our our state tree task, we somehow need to run that new EQS query that we created in order to get the location that we want our AI character to move to. So we'll create a custom event and we'll say run hide EQS. From here you can actually say run EQS query. You can pick the template, which is our hide location, and you can give it the querier, which is our character. And then you can choose what results you want back. Do you want the best item or a random item from the best 5 or 25%, or all of the results coming back? We'll just choose the single best item. Now you might think that once you've run this, what comes out of here, you can just drag off and say, so get query, you can get the actors or the location results. But that won't work because this is almost an async function. So if you do this, you'll end up with nothing. What you need to do is you need to bind to the event onQueryFinished. So once it's run that EQS query, which could be quite complex, it will then call this event. And we can then drag off and tell it to call our custom event. So EQS finished result. And from the query instance, we can now get the query information. So we can either get as actors or as locations. We set it, if you remember in our EQS, we're dealing with locations, so we want a pathing grid which will give us locations. You could also get actors of class, perceived actors, and so on, so the query would come through with actors. We're dealing with locations. So we'll say get query results as locations. We're getting the single best item here, so we could just say get a copy, and that will get the single result as long as it exists. So we can branch on that to make sure that it was successful. If query generated actors is filled with their locations, will be true. And then from here we can tell the AI controller to move to this location. So we could say AI move to. This will be where we want to move to. We can give it acceptance radius, maybe stop and overlap, and the pawn should be our AI character. When it either succeeds or fails, we'll keep it simple. We'll maybe put in a little delay before, and then we will finish the task. So hopefully, and on the event enter state, we will call run hide EQS. So that should hopefully run the EQS for us. Back to our state tree. We'll tell it when it succeeds or fails just to go back and rerun the task, the state again. So we'll say on completed, just go back to hide and flee again. So we can go back to our main level. We can now put our hide and flee character on the level, and let's just play, see if there's any issues. So first of all, the state tree doesn't seem to be working. And there seems to be a bit of an issue here, because on the state tree it says start logic automatically, and yet nothing seems to be working. So sometimes you do have to just say, grab the state tree and tell it to restart the logic. Now if we play, so now he's moving, but he's got no animation. And the issue with that is, if you go back to our hide and flee character, just click there and type in acceleration. You just need to click on the use acceleration for paths, because that's how it's set up in the animation blueprint that comes with Unreal. And now click. So now he runs. And he should hopefully, he'll keep looking for a location where we can't see him. So that's basic. Now the thing is, he keeps moving continuously. What we want him to do is, once he's found a location, we want him to check to see if the player can now see him, and then only move to another location. And the other thing is, we might want to add some more tests. So perhaps we want him to move to a location that is furthest away from the player and is maybe higher vertically or lower vertically from where he was previously. So let's start adding some of those. So if we go back to the we can do the test first. Can the AI character see the player or be seen by the player? So if we go back to our hide and flee, we can probably run another custom event first. So custom event, can player see me? And in here we'll do a trace. So we're doing a sphere trace in our over here for the player visibility, and that's using a sphere on the with a 30 radius. So we go back here, we can do a sphere trace by channel. We'll do this on the camera because we want to see whether the player can see our AI character, and we need the start and the end. So we can get our AI character, and we can get player character. Basically, we want to, from the player, we want to get the player's eyes. So we can say get eyes, actor eyes. That can be maybe the start. And we can say get actor eyes. And put that as the end. Give it a radius of 30 like we did in the EQS. On the camera channel, because both will block that channel, and we'll ignore our AI character so it doesn't block. And we'll do a draw debug maybe for 0.2 seconds. So now we can break this. If we get a hit, we can, because we're checking if the player can see us, we want to know if the hit actor is equal to the AI character, because it's starting from the player's eyes. And if that is true, then we want to run the EQS query, isn't it? So run the hide EQS so it can find us a new location to move to. If it's false, we don't want it to do anything, so we can just tell it to finish the task on both of these. And instead of the run hide on the enter state, we'll tell it to do the can player see me. So now we get this so that didn't work, and I think the reason is where we've done something the wrong way around. We go back to our hide and flee. First thing is, because we're doing it from the player's viewpoint, we actually want to ignore the player, not the AI character in our actors to ignore. That will probably fix it. The other thing is we're getting a lot of those line traces, so we could just put a little delay here in between each one. And now if we try it again, so he runs off, then we do a line trace to see can we see him. Again, whenever it gets blocked, so again it's getting blocked by that wall. And as we start to chase, he should start fleeing to a new location. But again, he's not always going where we want him to. So let's add some more of those tests we were talking about so that the character chooses a point that is furthest away from where the player is located to flee to. So we go back to our EQS and we can add another test on here. This time we can do a distance. We want to do a check from the context, from the player actually, isn't it? So the player context, and we can choose 3D or 2D or on the rest. We'll keep that at 3D. We'll leave the range, we'll just score this, so this will be a score, not a filter, and I think we can leave the rest there. So let's see what happens if we click on this guy. So again, it should be choosing the points. You can see they're being scored here, 0.7, 0.8, and the ones that are furthest away, 0.95, should be the one that the actual player, the AI character, moves to. And these ones are all, even though they are hidden, they're 0.74. So it's doing that. Maybe we wanted to also use height as a test. So we go back to EQS there. We could also maybe add another test. Distance. We'll choose the same player again, player context, to do our testing on. We could maybe just do the distance Z on this, and give it a range from 0 to, just make a large number, 1500. We can leave the clamping. So linear will mean that the higher the Z value is, the higher the score it receives. If you wanted it to be the opposite, you would choose inverse linear. A constant will just give you basically what the scoring factor is, and the rest is just some mathematical changes. And we can leave everything else there the same. So again, hopefully the higher ones, with the Z is higher, scores more. So as you can see, that one now is scoring 1. Because it is higher up than this one and further away. Let's just play that. So now he chooses, goes up there, checks to see where we are. When we see him, he runs away. And he should keep fleeing from where we are and checking to see whether we can see him or not. And every time we can, he'll choose another location that is not fully visible. He goes up. So again, this is a bit of an issue, isn't it? He runs, he's not avoiding us in the navigation. So one thing you can do is you can open the hide and flee character, and you can check here for something known as AVO avoidance or RVO avoidance. Tick on that. It should try to add some sort of avoidance radius when it's running the navigation, the AI movement on it. The other things you can sometimes do is on your actual character itself, you can add a navigation, a nav modifier, set it to a null area, and basically if you look back at our character, so you'll notice that this navigation around it is set to be null, that cannot be passed. And so the points that it's finding will avoid that navigation area as well. So if we run it again, now he runs up there, goes across, checks to see where we are. He's sort of disappeared now, fleeing from us. Sees us again, now he runs down there. As we start chasing him, he should keep fleeing. Hides again, we can't see him. See him again, now he runs up, finds a place to hide, sees us, runs away again. and essentially he should keep running away from us and not colliding with us this time. So I hope that explains how to use the state tree with the EQS feature and how to run an EQS function query. So the most important thing is when you run the query that you can't use the results straight away because it won't be valid in most cases. So you need to do the onQuery finished callback, and then you can access the information that you're after. And these EQSs can be as complex as you want them to be. You could run multiple, one after the other, and all sorts of tests that can be added: distance, dots, gameplay tags, traces, and all the rest. So again, it gives you some quite sophisticated artificial intelligence that you can incorporate into your game, and just takes a bit of experimenting and testing to understand what all the criteria and tick boxes mean.